Yes. Hi students, all of you welcome. Welcome to Sunil Engineering Academy. Are you getting my voice? I think you are getting my voice also. Yes. Students, I think all of you know very well. Recently, SSC released SSC JEE notification 2022. Okay. So from today onwards, we are going to discuss topic-wise MCQs. So this will be useful for all your competitive examinations. So I'm starting with the transformers. So please share these links to all your friends. Okay, then I can continue these classes uh, to all the subjects also. Okay, so let us start the session, guys. So coming to the first question, which of the following does not change in a transformer? Which of the following does not change in a transformer? Come on, try, all of you. Which of the following does not change in a transformer? Here we know very well, transformer used to step up or step down the voltages. Step up or step down the voltages. Okay, and in the transformer, the power is always constant. Power is always constant. That means product of voltage into current is equal to constant. Okay, so in the step up in the means voltage is increases. So it step up the voltage means voltage is increases. As the voltage increases, what about the current? To get the constant power, current will be decreases. So voltage increases means automatically current is decreases. In the same way, step down means voltage is decreases. So the current will be increases. So what are the variable quantities here? What are the variable quantities here? Voltage comma current. These two are variable quantities. Which are constant quantities? Power is the constant and also frequency is the constant and the amount of flux also constant. Okay, so amount of flux or magnitude of flux. Magnitude of flux also constant. So these three parameters are constant and voltage and currents are changes. So does not change. Voltage, currents are changes, but frequency does not change. So we can give the answer as option C. We can give the answer as option C. Okay, all of you clear? Coming to the next question. In a transformer, the energy is conveyed from primary to secondary dash through cooling oil, through air, by the flux, and none of the above. And none of the above. Welcome, Aniswaral. Please share the session to all your friends. Yes, here energy is conveyed from primary to secondary by the flux. By the flux. Why? Because here if you can consider any transformer, here this is the core of the transformer. Okay, here we have one winding, here we have another winding. So there is no direct connection between the two windings. So can say electrically isolated. Electrically isolated. And here magnetically coupled through the core. Magnetically coupled through the core. Magnetically coupled through the core. Okay, so whenever you are giving the supply to the one winding, then current is flowing, then flux is producing. That flux will be transferred through the core to the secondary. Okay, secondary winding. So here energy is conveyed from primary to secondary by the flux. Answer is option C. Coming to the next question. Transformer action requires dash. An increasing magnetic flux, decreasing magnetic flux, constant magnetic flux, alternating magnetic flux. Come on, very easy question. Very easy question. Coming to the principle of the transformer. What is the principle of the transformer? Faraday's law of electromagnetic induction. Faraday's laws. Okay, in this particularly you can say mutual induction. Mutual induction principle or mutual inductance. Okay, so in this, according to the Faraday's law, an EMF will be generated. Here there is no rotating parts. Here statically induced EMF is developed, minus N d pi by dt. So minus is Lenz's law. Okay, so whenever there is a flux is changing with respect to the time. So whenever there is a time varying flux, then an EMF will be induced. Okay, so we require time varying flux. Time varying flux in the sense alternating flux. We require alternating flux. If the flux is constant, then d pi by dt is 0. Whenever the d pi by dt is 0, then EMF also 0. So the primary is going to be 1. So that's why we require alternating magnetic flux. In case of DC machines, guys, in case of DC machines, they're dynamically induced EMF. So in case of dynamically induced EMF, we require constant flux, time invariant flux. Okay, time invariant flux, time invariant flux. Okay, in case of transformer we require time varying flux or alternating flux. Coming to the next question. In a transformer, the primary flux is always dash the secondary flux. Primary flux is always dash the secondary flux. Come on fast, guys. The primary flux is always dash the secondary flux. So here just I said, which are the constant terms? Frequency, power and magnitude of flux, all are constant. So that means whatever the primary flux, that is always equal to secondary flux. So we can give the answer as option C. Okay, very good. Soham Biswas. Coming to the next question. A transformer is dash. All these are basic questions, guys. So after this we will discuss medium level and difficulty level questions also. Okay. What is the answer? A transformer is dash. So just now I said transformer step up the voltages. Whenever the voltage is step up, current is automatically stepped down. Okay, it can step down the voltage. In this case, automatically current is step up. Okay, and the transformer requires time changing the flux, time variant flux. That means we require AC flux, AC. Okay, so it step up or step down AC voltages and AC currents. AC voltages and AC current. If it is step up the voltage, automatically current is stepped down. If it is step down the voltage, automatically current is step up. Okay, so we require time varying flux. So that means AC only. For DC, what will happen? Transformer may not works for DC because of the flux is not at all changing, so EMF produced will be 0. So whenever there is no opposing primary winding, resistance is very less, so high current is flowing, so primary is going to be burn. Okay, that's why transformer is not operated on DC. Coming to the next question, guys. A step-up transformer converts dash into a dash. Step-up transformer converts dash into a dash. Another very easy question, guys. So step-up transformer, it step up the voltage. Step up voltage. Okay, so if you can consider it is the step-up transformer, you are giving low voltage to this one and it will convert into high voltage. Okay, so low voltage in the sense, what about the current? Current is high. High voltage in the sense, current is low. Low current. Okay, clear? So step up transformer converts low voltage at high current to high voltage at low current. So the answer is option C. So the answer is option C. Very good, Soham Biswas. And coming to the next question. Primary winding of a transformer is dash. The primary winding of a transformer is dash. Coming to this transformer, so there is no primary winding, no secondary winding like that. Okay, so any transformer having two windings in these, one is the HV winding, one is the LV winding. So higher number of turns HV winding, lower number of turns LV winding. Okay, so in this, if you are giving the supply here, then it will becomes the primary winding. If you are giving the supply here, then it will becomes the primary winding. Okay, so the winding which is connected to the supply. Okay, the winding which is connected to the supply. Primary is nothing but winding which is connected to supply. To supply is called as primary winding. In the same way, the winding which is connected to load, winding which is connected to load is considered as the secondary winding. All of you clear? So in any transformer we have the two windings, those are LV and HV windings only. The winding which is connected to the supply, primary winding. For example, if you connect supply here, it will become the primary winding. Okay, so the primary winding may be HV winding or LV winding. If you connect the HV side, it will become the primary. If you connect the supply to the LV winding, then it will become the primary. So it could be either low or high voltage winding. It could be either low voltage or high voltage winding. Okay, coming to the next question. Very good, Priyadarshini. In the transformer, the following winding has got more cross-sectional area. Which winding has more cross-sectional area? Very, very important question, guys. Which winding having more cross-sectional area? Yes, let us understand. Cross-sectional area requirement is depends upon the current. Always the area we will consider depends upon the current rating. Depends upon the current rating. Okay, so it has more cross-sectional area. More cross-sectional area required for high current rating. So high current in the sense, what about the voltage? Voltage is less. Okay, so for low voltage winding having high current, For high current, we require more area. So low voltage winding having more area or more cross section area. So the answer is option A. Very good, students. Very good. Coming to the next one. Which winding in transformer has more number of turns? Which winding in a transformer having more number of turns? Okay. And students, I have given my Telegram link in the description box. All of you click on the Telegram link and join in the Telegram channel. After the session, after half an hour or 1 hour, I will give this PDF in the Telegram group. Okay. So all of you, please join in the Telegram. Which winding having the more number of turns? Yes, very good. So high voltage winding having the more number of turns. We know very well the voltage ratios is nothing but respect to number of turns. Okay. So as the number of turns, for example, number of turns are more, then the corresponding voltage also more. Okay. In case of step up transformer, generally what you are taking, so n1 will be less and n2 will be more. So because of the higher number of turns, the voltage values are also higher. Okay, the voltage values are also higher. In case of step down transformer, primary winding turns having the more than n2. Okay, then that voltages are also, secondary voltage also low. So we can say high voltage winding having more number of turns, low voltage winding having less number of turns. The transformer used for AC welding set. The transformer used for AC welding set is dash. Used for AC welding set is dash. So in case of welding set, what is our requirement? We require low voltage, comma, high current. So we can get from which transformer? Low voltage, step down. So from the step down transformer, we can get the voltage is low and high current. So step down type. So the answer is options. Coming to the next one. An isolation transformer has primary to secondary turns ratio of dash. Primary to secondary turns ratio of dash. Very important question, guys. Yes, very good. So isolation transformer used for isolation purpose. Used for isolation purpose. Okay, so it has the turns ratio is 1:1 only. So if the turns ratio is 1:1, it is not stepping up or not stepping down the voltages and currents, then what is the requirement of this? So where we can use this isolation transformer? In case of some specific instruments, specific or dedicated instruments, like medical applications. In case of medical applications, and if you are using, if you are handling very high powers, then there is a chance of shock, electrical shock. Okay, so to avoid the electric shock, we are using these isolation transformers. Okay, so if you are using direct contact, then what is happening? So if you touch any accidentally, then there is a shock. But in case of transformer, the energy is transferred through magnetic, not electric. Okay, so there is a less chances of the shock. Okay, so in that cases, we are using this isolation transformer. So that is 1:1 only. What will be the transformation ratio of 550 volts to 110 volt 50 hertz single phase step down transformer? They are asking transformation ratio. In transformation ratio. Very, very important question. Students, don't confuse with turns ratio and transformation ratio. Turns ratio is denoted as A, that is equal to N1 by N2. In the same way, transformation ratio is denoted with K, that is nothing but N2 by N1. Okay, so we can also denote N2 by N1 is equal to E2 by E1, that is equal to I1 by I2, that is equal to K, that is equal to K. So N2 by N1 is equal to E2 by E1 now. E2 by E1 means 110 by 550. So 1 by 10. So that is uh, sorry 1 by 5, 0 0.2, 0 0.2. So the answer is option D. Answer is option D. Okay, all of you clear? So transformation ratio is nothing but N2 by N1 or E2 by E1 or I1 by I2. Turns ratio is nothing but N1 by N2. So you can say K is equal to 1 by A or A is equal to 1 by K. A is equal to 1 by K. Okay, coming to the next question. In single phase 50 Hz transformer has a voltage rating 2200 by 220. The transformation ratio is dash. The transformation ratio is dash. Very easy question. Same like previous. Same like previous. Transformation ratio is K. That is nothing but E2 by E1 or V2 by V1. So 220 by double two double zero. Ones, tens, that is equal to 1 by 10. So the answer is option C. Okay, coming to the next question. In a transformer, the resistance between the primary and secondary is dash. In a transformer, the resistance between its primary and secondary is dash. We know very well. In case of the transformer, the two windings are electrically isolated. That means if it is a core, here insulation, upon the insulation you have the one winding. Here also the insulation, upon the insulation you have the winding. So that means two windings are electrically isolated. Electrically isolated. Okay, electrically isolated means what is the resistance between primary and secondary? Zero, infinity na, primary and secondary. So open circuit, that is almost infinite. Infinite. So the answer is option. Okay. Students, you can get this PDF in Sunil Engineering Academy Telegram channel. So I have given the link in the description box. So please click on the link and you can get the PDF of this class. Okay. And if you have not subscribed this channel, please click on subscribe button and also please share this information to all your friends. And you can also get SSC JE Plus courses in UNACADEMY Plus subscription. UNACADEMY is India's largest learning platform. You can download the UNACADEMY app from the Play Store and you can select your goal as SSC JE and State AE examination. Select the number of months, enter the referral code Sunil Sir SSC. Okay, this is the referral code Sunil Sir SSC. And go for the subscription. After subscription, you can get all the plus courses under this SSC JE and AE exams category. Okay. Okay, students, we will discuss the remaining questions in the next session. all of you. Thank you so much for watching. Take care. Bye, guys.